Okay, let's start our lecture today. Uh, mouse. Okay, so let me see, where did I left off last time? Uh, mm, okay, yeah. So we are left to show that this U is even covered by this gamma, right? So so to show that this U is even covered with gamma, okay. Okay, yeah. So remember that last time we showed that this gamma inverse of U is equal to this, like the gamma acting on this U naught, and then is equal to the union of the set of all, the union of this small r in this gamma r of U naught. Yeah, so we showed that last time. Okay. So now let's show that so to show that, okay. To show that U is evenly covered by gamma, it suffices to show that these sets are all disjoint. And then gamma maps each of these sets. So last time. So we show that this gamma inverse of U is equal to union of small r in this gamma approximation group of this r of U naught. Okay, so this is what we showed last time. Okay, so to show that this U is evenly covered by this gamma, it suffices to show that these are all disjoint. Okay. To show that this collection are disjoint. And then gamma, you straight out this set. Okay. From R of U naught to this U is a homomorphism. Okay. All right. So let's see why this is these are all disjoint. Let me see. Okay, so let's see why they are all destroyed. Okay. So why these are all destroyed? Okay, so this R is like, okay. Okay, so why they are all this? Oh, yeah. So this R is, I think this R is like I think wait. So properly discontinuously. Okay. Wait. Okay, let me think. So we know that this R acts properly discontinuously. Mm. Oh. Okay, so properly discontinuously means what? So okay, I know that this R acts properly discontinuously. Okay, so what does that mean? So that means that if you take, let me think. So okay. Hmm. Okay, I think this has something to do with the U now, right? So so let me see what is the definition of the U now. So okay, so this U naught is being chosen such that yeah, so last time, last time we chose this U naught to be the connected neighborhood of this Y naught with okay, so we choose this U naught to be the set that's being contained in this set, right? Contained in this V intersect the intersection of this small r is gamma 1 V of this R. Okay, so intersect this R inverse of WR. Okay, and then oh. Okay, so actually I think it might be a good exercise for me to just try to show that, because I think yeah, okay. So let me try to see what I can do with these settings. So, yeah. So we're trying to say that the proof, yeah. Okay. So here, we know that this, okay, so this V is what? We know that this V is, okay, so what is our setting? Okay, so let me remind myself. So what is setting? So, so here we are given like a point x naught, right? A base point in this x. Where again this x is like the it's like the quotient space, right? It's like the quotient space by this relation by gamma, and then so basically what you really do is that you kind of fix we fix the equivalence class, and then what you get is that so basically you think of this as the projection, and then you think of the equation as the set of points such that so gamma so the point they are always like, for example, gamma of x naught, right? So for example here is x naught, and then right, so here maybe let's say gamma 1, small r of 1, small r of 2, and then small r of 3, so on and so forth. And these are all self-homomorphism. Okay. Okay, so okay, so again, let me think. Okay, so we fix a point y naught in this gamma inverse of x naught. Okay, so fix a point y naught. So let's say that we fix a point. This is our point y naught. Okay. So let's delete this. Okay. So okay, what we do is that we pick a relatively compact neighborhood V of y naught. Okay. Okay, so we pick a relatively compact neighborhood V. Okay. So this V may or may not contain this point. So I just draw that. Okay. So this is V. This V is relatively compact. Okay. Relatively compact neighborhood of this y naught. Okay. And then and a finite set. Okay. Okay, and a finite set. Okay, so this gamma 1 is a finite set, right? So it's a finite set where okay. So gamma 1 is a finite set, okay. Such that you have this R of V intersect V is not empty. Wait, okay. It is empty for each sorry, this R is in this gamma take away gamma 1. Okay. So basically, because it's act probably discontinuously on this, because this we know that this gamma act probably discontinuously on this x tilde, right? Yeah, and then because that implies that for each point we can pick such neighborhood where you have the intersection is not empty for only finitely many set. Okay, so therefore it's empty for the else. Yeah. Okay. So then let's see what happened. So then wait, why? Oh, yes. You can, yes. This V must be compact. Yes, this V must be compact. Okay. Yeah. But by definition, this is the compact set. But here we take to be the relatively maybe take it like take the interior of the compact set. Okay. Yeah. Take the interior of the compact set. Yeah. Okay. Wait. What happens if the compact set is take the interior of the compact set? Yeah, that should give you a relatively compact. Hold on, I don't think. Oh yeah, for every compact set k in X. Okay. Okay, I think sorry, I messed up with the because I messed up with the order because so first, because this X tilde is a locally compact Hausdorff space, right? So therefore, for each point V, I fix a point right now, and then I just wait. So again, sorry. Let me say it carefully. So okay. So okay. So acting properly discontinuously means that whenever we have this equivalent statement of acting properly discontinuity on this x tilde. So namely, for each pair of points x, y, there is a neighborhood u of x, v of y, such that this R of u intersect v is empty for all but finally many element R of this gamma, right? So then what you do is that you specify these 2 points to be the same point, right? And then you, for that neighborhood, because this is a relatively because this space is a locally compact Hausdorff, so we can pick a relatively compact set that's being contained in this neighborhood. Okay, and then let me check. Yes. Yeah. This is how. Yeah. Okay. Right. Yeah. Okay. Okay. So yeah, that's how you choose the relatively compact. Yeah, that's how you choose the relatively compact set. Okay. Good. Okay. So now yeah. So gamma one is finite such that this is empty and then yeah for each yeah this is true. Okay. And then um uh yeah. So why they are destroyed? Okay, so I know that this is V, right? So then, oh, okay. Okay, so this is what V is. And then, so what else can we say? So we know that this is V intersect this, okay. VR U intersection R inverse of WR. Wait, what is VR WR? Oh, okay. Oh, I see. Okay. Yeah. So remember that this VR and WR they are chosen such that. So yes. So this way. Yeah. So remember the way we define this VR and WR is that we choose. Okay. So here this VR is the neighborhood of this y naught, right? So this V, okay, so for each R, okay, so for each R, we choose this VR to be the neighborhood, yeah, so for each R, okay, so for each R, so say, for each R, so for each R in this gamma 1, okay, so basically what we do is that we choose this VR to be the we choose the VR to be the neighborhood of okay, but I think maybe it's better to say it this way. So for each R in this gamma 1, okay, so we can choose because this yeah, so we choose the VR and this WR to be the neighborhood of this y naught and this R of y naught, right? Such that they are discrete. Okay. Yeah, because it's a Hotterl space, we can do that. Okay. Okay. So yes. Okay. I see. Okay. Oh, okay. So I think the reason why it is destroyed is that. So wait. Okay. So this u dot is in this set, right? So imagine you take any r in this set, right? Yeah, imagine you take any r in this set. Because this u is contained in this v, right? And then we know that this r of v intersect v is empty. Wait. Wait, I messed up. Okay. Okay. Sorry. Hold on. Give me one. Let me see. Wait. So okay. So what is the reason to believe that these are disjoint, right? I want to show that they are disjoint. So why they are disjoint? Okay, so let's take a look. Let's take a look at what they are. So, okay, so this is V, right? And then, what is this VR? So this VR is what? Yeah. So this VR is a neighborhood that. Okay, I see. So wait. So this VR is the neighborhood that okay. So okay, so you see, okay. So here this VR is a neighborhood that is, yeah, if you okay. So this VR is a neighborhood that if you, so namely, right? So namely intersect is WR is empty. Okay. So what is WR? So this WR is exactly the set of, it is a neighborhood of this R of y naught, right? So yeah. So namely you think about, like, if you have this y naught here, and then for each r in this gamma 1, what you do is that you can apply this r to this y naught, okay, and then you will get a point. Let's say, so this is a y naught. Then you apply r to it. You get another point on this fiber, and then what you do is that you pick this neighborhood. Yeah, you pick this neighborhood so that these two are disjoint. Okay. And then okay, then what? Wait, what do you want to say? Yeah, so these two are disjoint. Okay. So what do you want to show? want to show that these are disjoint, right? So this R of U naught are disjoint, right? Where this U naught is all this, yeah, it's all this intersection. So okay. Okay, so I think the idea is that if you take this V, okay, so for this R in this gamma 1, if you take the intersection of this VR and this R inverse of WR, right? So this is like VR. Yeah, this VR. Yeah, I specify R. Yeah, I specify R here. This is my VR. And then imagine that you also have this let's say R inverse of, oh, this is your WR. Okay, so yeah, so you fix the R, okay. Okay, and then this is R inverse of, so this one is like the R inverse of WR, right? Then you take the intersection. Okay. So once you take the intersection, yeah. So after you take the intersection, I want to say that. Okay. So I want to show that. Okay. So I want to show. So you take the intersection, intersect, and then I take the image again, and then I think it will intersect. This is a non-empty intersection, or sorry, empty. Okay, this is what I want to show. Okay. Okay, so let's see why. Okay, so if you take any, element, let's say x. Okay, so let's say if not, so then there is say x such that x in this B R intersect R. And x in WR, right? And then so this implies that x okay. So maybe there is x prime in this VR intersect R inverse of WR such that so this implies that oh, okay. So here, yeah, okay. So this implies what? So since this, okay. So since this, okay. So since this x prime is also in this R inverse of WR, right? So this implies that R of x prime is equal to this is in WR. Okay. Yeah. Okay. So wait. Why is okay, so yeah, so what is the reason to believe that this set their intersection is must be empty? What is the reason? Okay. So okay, so okay, so this is WR, right? So this is WR. And then we take the WR gamma, wait. I don't think they are empty. Okay, I don't think they are empty. Oh. Wait. Okay, my bad. So I should say they are disjoint. Okay. So okay. So why they are disjoint? Okay. Sorry, my bad. So they are disjoint. Okay. So why they are disjoint? Okay. Okay. So namely what I do is that okay. So this is one set, right? We are in a set. Okay. Okay. So why they are disjoint? Of course they are disjoint because these are disjoint, right? Yeah, so because these are disjoint, so therefore these two sets they are disjoint, right? Yeah, okay. So okay. Yeah, I think okay. So that tells you what? That tells you that oh, okay. Okay. so let's try to lay out the proof here. Let's try to lay out the proof. Okay. So okay. So wait. Okay, so yeah, so the idea is that, so right, so this is true, yeah. So the idea is that, I think the idea here is that, so basically, so this is like the open set that's being contained, that contains this U naught, right? So basically, this U naught lies in this V, and then it lies in like each of this R in this gamma one, right? So here I specify like a. Yeah, so here I kind of specify like 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 pair of intersection of this pair of set. Yeah. So here I specify it to be that. Okay. So yeah. So yeah, I think the idea is that like this U naught, right? So if I take any, yeah, so we can kind of split this R into like two separate cases. One case is where this R is in this set. Okay. So when R is in this set, I think it's covered by this V, right? Yeah, I think it's covered with V. Okay, because this V is like you have this RV, and then right, it is equal to it's empty set. Okay, essentially it's empty. Okay, so for this RV. Wait. Okay. I want to be a little bit careful here. Because, so, yeah, the thing I'm worried about is that, what happened, yeah, I want to show that these are all destroyed, right? I want to show that these are all destroyed. So I think just the empty with the original set is not enough, right? You want to say something more about it? Yeah. Okay. So let's see what happened. So if you pick any, okay, so what is the reason to believe that if you pick any, okay, so let's start with the easy case. Okay, let's start with this case where this R is in gamma 1. Okay. Okay, so if R is in gamma 1, then what is the reason to believe that these are all disjoint? Okay. Okay, I think maybe it's better for me to lay out the set here. Okay, okay, so let's say that we have this okay, so let's say that we have this R and R prime. Okay. Okay. Okay, so let's assume that this R is not the same as this R prime. Okay. Otherwise, yeah. Otherwise, it's trivial. Okay. So then, okay. So then, what do we have? Yeah. So what we have is that. So let's take a look at this R of U naught. here, okay, so here you are taking just these two intersection of this some portion, yeah, you're just taking some, yeah, so here there are these, you think of these are many open sets that we take intersection, right? So here this is only some portion, only like, yeah, only two of them, right? Only two of these set, okay. So and then and then so this is the portion that corresponds to this is the portion that corresponds to this R, right? So we fix R, right? So again, so here, okay, so even though we use the same name, but yeah, so just imagine that this R is like this R, okay, and then basically here is taking all the different R's in this, all the R's in the scalar one, right? So basically we can take another R prime, right? So this is R prime, okay, we take another R prime. So R prime, we get this, this is Y now, right? So for the R prime, we'll get this one as R prime, maybe somewhere else, okay. I was a little bit funky here, so namely it should be in the fiber, but sorry, I put it here, okay. Okay.